Today we will be looking at 4.1, which is dealing with inverse functions. So to start, one-to-one function, what is it? Well, it's one-to-one if for elements a and b in the domain of f, a is not equal to b implies f of a is not equal to f of b, or different values of the domain correspond to different values of the range. So let's go ahead and take a look at these to determine if we can figure out if these are going to go ahead and be one-to-one. So our first one, f of x is equal to negative 3x plus 7. What we want to essentially show is that f of a is equal to f of b, which leads to a is equal to b. And if we can show that, then we can say that this one is going to go ahead and be one-to-one. So first thing we're going to go ahead and do is go ahead and plug a into our f of x. So every time we see an x, we're going to go ahead and replace that with an a. So negative 3a plus 7, and again we want to take care of the f of b portion, so we're going to go ahead and plug b in for x now. So that will give us a negative 3b, and then finally plus a 7. Now we want to go ahead and see if we can get a equal to b, and if we can, then this is going to imply that we have a one-to-one function. So let's go ahead and subtract a 7. So that will get me a negative 3a is equal to a negative 3b. If I divide by negative 3, divide by negative 3, what am I left with? A is equal to b. So therefore we can imply that this one is one-to-one. All right, let's go ahead and look at a couple more examples here. So b and c. So b, we're dealing with these bubbles here. We have our x values and our y values being mapped. So 1 is mapped to 5, 2 is mapped to 6, 3 is mapped to 6, 4 is mapped to 7, 9 is mapped to 8. So in this case, since we have the 2 and the 3 mapped to the 6, this one is not one-to-one. So not one-to-one. Okay, let's go ahead and look at C here. Notice how every element is only mapped to one element in the x and the y. So 1 mapped to 5, 2 mapped to 6, 3 mapped to 7, and 4 mapped to 8. In this case, since each x value corresponds to one y value and vice versa, this one is going to be one-to-one. Okay, let's go ahead and look at D. So now we're dealing with the square root of 49 minus x squared. Again, we want to go ahead and plug a and b in here and then set them equal to each other to see if we can have a equal to b, which would imply one-to-one. So let's go ahead and plug a in for x. So that will get us the square root of 49 minus a squared equal to, and now we need to take care of the b portion. So 49 minus b squared, and we're taking the square root of that. So in order to get rid of the square root, we can go ahead and raise it to the second power. So now what do we have left? Well, we have 49 minus a squared equal to 49 minus a b squared. Now let's go ahead and subtract a 49. So subtracting the 49, we are left with a negative a squared equal to a negative b squared. And if we were going to go ahead and divide by negative 1, we would then get a squared is equal to positive b squared. And in order to get rid of this square, we can go ahead and take the square root. So that will leave us with, and when we take the square root, we want a plus or minus a equal to a plus or minus b. Now, what we really wanted was an a is equal to b. In this case, we have a plus or minus a equal to plus or minus b. So this isn't really what we wanted, because we could have a negative a is equal to a positive b. We could have a positive a is equal to a negative b, but not necessarily a is equal to b. So another way to show this is if we plug in a value of a negative 3 in and a value of a positive 3, what happens is we get the exact same value, and that is not showing that we have an x value corresponding to only one y value and vice versa. So that will leave us with a 49 minus a negative 3 squared, as well as a 49 minus a positive 3 squared. And what is that going to leave us? It's going to leave us with the same value of a square root of 40. So in this case, this one is not one-to-one. Okay, so we can go ahead and move on to our horizontal line test, which we can perform on graphs in order to determine if they are one-to-one or not. So let's go ahead and look at our first example here. So essentially what the horizontal line test is, a function is one-to-one for every horizontal line intersects the graph if we only intersect at most once. So when we draw a horizontal line, we want to see if we only cross once, then we are good to go, and that one is going to be one-to-one. Now, if we cross more than one, or say twice or 3 times, then that one is not one-to-one. So for this first example, notice how if I draw a horizontal line, we will only cross at 1 point. So therefore we can conclude that this one is going to be one-to-one. Now for our second one, notice what happens if I draw a horizontal line here. We will intersect twice, and that is not what we want, so this one is not one-to-one. All right, our third example here, this one is going to be one-to-one. Notice how if I draw a horizontal line, we will intersect at most once, so this one is going to be one-to-one. All right, and additionally, we can look at some of these other examples here. So we're dealing with some of our rational functions. This first one, notice how this one is not going to be one-to-one. I will cross twice, so not one-to-one. Additionally, let's look at our last one. This one is going to be one-to-one because it doesn't matter if I draw a horizontal line here or a horizontal line down here. We will cross at only 1 point. So this one is also one-to-one. Okay. So tests to determine whether it is one-to-one or not. Let's go ahead and look at these. So number one, we can show that f of a is equal to f of b, which implies a is equal to b. If you get a is equal to b, you can say, okay, this one is one-to-one. Now, number two, you know that it is going to be one-to-one if every y value corresponds to no more than one x value. To show that not one-to-one, find at least 2 values that produce the same y value. So an example of number 2 was this example right here of d, where we picked that value of -3 and +3, and notice how they produce the same values. So that's another way you could show that it is not one-to-one. Now let's go ahead and look back at our test to determine whether one-to-one. Number 3, what we just looked at, you could sketch a graph and use the horizontal line test, and if it crosses 1 point, then you're good to go. If it crosses at more than 1 point, then you can say this one is not one-to-one. Now number 4, if a function either increases or decreases on its entire domain, then it is one-to-one. So if we go ahead and look back up at our examples, notice how if it's increasing or decreasing on its entire interval, so let's go ahead and highlight this. This one is decreasing on its entire interval. This one was one-to-one. Now the second one, it's increasing and then it's decreasing. Our final one is going to be increasing on the entire interval. And then finally, in this last one, we're going to have increasing then decreasing, so not one-to-one. And then finally, we'll have decreasing on the entire interval. Okay, so that should do it for our different types of tests. So now we can go ahead and look into something called inverse functions. So inverse functions, these are going to be certain pairs that undo one another. So say for example, we had g of x is equal to 8x plus 5, and f of x is equal to 1/8 x minus 5/8. So if we evaluate the same number 10 or some sort of number with g of x, so we're plugging in 10 here, we will get 8 times 10 plus 5, or in other words, we will get a value of 85. Now, we can conclude that g of 10 is going to be equal to 85. Now, if we take this 85 and then plug it back into our f of x, we should get the value of 10. So if we look here, we will have 85 in for our f, and we have 1/8 times 85 minus 5/8, or in other words, that's 88ths, or that's a value of 10. So notice how they, in some sort of way, undid each other. So what can we conclude? G of x and f of x contain inverse operations that undo one another. So we can summarize it by saying that f of g of x is equal to x, or g of f of x is equal to x, or in other words, we could go ahead and say, with our notation here, we could say f of g of x, or we could say g of f of x, and they are equal to x. And the final conclusion is that f and g are going to be inverses. So, an inverse function. Let b be a one-to-one function, so that is the first requirement. Then g is the inverse of f. So, f of g of x is equal to x for every x in our domain g, and g of f of x is equal to x for every x in the domain of f. But the biggest thing is that we have to be dealing with a one-to-one function first before we can go ahead and try to find its inverse. So now let's go ahead and try to determine if two functions are inverses. So let f of x, or let functions f and g be defined by f of x is equal to 2x plus 5, and then g of x is going to be equal to 1/2 x minus 5. Now, we want to see if g is the inverse of f. So let's go ahead and try to see what we can do with these two different types of functions. So the first thing, if you recall, we want to go ahead and see if it is indeed one-to-one. So let's go ahead and perform step 1. We want to go ahead and check if it is one-to-one. So if 1-to-1, because that will be our first requirement in order to find our inverse. So we're looking at, in this case, our f of x is equal to 2x plus 5, and we want to see if that's, we can find some sort of inverse, or g of x equal to 1/2 x minus 5. So if we go ahead and graph 2x plus 5, we will have some sort of line that looks like this. Now, in order to determine if this is one-to-one, remember we need to go ahead and perform a vertical or a horizontal line test for some sort of function to determine if it is one-to-one. So we will cross at only one point, so we are good to go, and we can go ahead and move on to step 2. So step 2, what do we need to do? We need to find f of g of x and g of f of x. So let's go ahead and do so. Step 2, we want to find, in this case, f of g of x and g of f of x. So g of f of x. So let's go ahead and try to find f of g of x first. So f of g of x, what will that produce? That will give us, in other words, f of g of x. And we can go ahead and take our g of x and plug it into our f of x. So our g of x is going to go ahead and be, in this case, this 1/2 x minus 5, and we take that and plug it in every single time we see an x in our f of x. So in this case, what will that give us? That will give us a 2 times a 1/2 minus 5, and then finally plus a 5. So that will give us an x minus 10 plus a 5, which is equal to an x minus a 5. Now let's go ahead and try to figure out if our g of f of x gives us what we want. So g of f of x, what will that give us? G of f of x is going to be equal to g of f of x. So every single time we see an x now in our g of x, we replace that with our f of x, or 2x plus 5. So what will that produce? That will give us a 1/2 times 2x plus 5 minus a 5. Or in other words, that will give us an x plus 5/2 minus a 5, which is equal to x minus 5/2. So step 3, we need to do some evaluation and figure out if this is what we wanted. So step 3, we'll go ahead and write it down here. So step 3, what essentially we wanted was f of g of x and g of f of x equal to x. So let's go ahead and evaluate to see if this is what we wanted. Notice in this case, what did we get? Well, we got x minus 5 and we got x minus 5/2. So this is not really what we wanted. In this case, they're not that, so the inverse is not going to happen. So how can we conclude this? In this case, they are not. So g is not the inverse function of f. Right? Because our f of g of x was not equal to x, it was equal to x minus 5, and our g of f of x was not equal to x, it was equal to x minus 5/2. So, all right, let's go ahead and move on. Finding inverse of one-to-one functions. Now, we're going to go ahead and try to find the inverse of these different types of functions, and again, we need to make sure that they are one-to-one before we can perform any types of operations trying to find out what the inverse is. So our first one, we're dealing with some ordered pairs within a set. So f is equal to, and we have a bunch of these ordered pairs. Let's go ahead and see if we can find the inverse of this one. So is this one one-to-one? We need to go ahead and figure out, is it one-to-one? So we have a -2 mapped to a -8, a -1 mapped to a -1, 0 to 0, 1 to 1, and 2 to an 8. Notice how we don't have any x's repeating or any y's repeating, and they are all mapped to one x and one y, and vice versa. So in this case, we actually can find the inverse. Let's go ahead and try to find it. So our f inverse, we can find this by simply taking our x's and our y's and interchanging them. So I'll go ahead and write a note, interchange x and y values to get inverse. Okay, so again, we can go ahead and take our x and y values and interchange them. So that will give us these values. 0 and 0 is just going to give us 0 and 0. 1 and 1 will give us a 1 and a 1. And then finally, our last values will be an 8 and a 2. So this should give us our f inverse. All we did was interchange our x and our y values in order to get our inverse. So we are good to go with our part A. Let's look at part B. So we have a -2, a 5, a -1, 2, 0, 1, 1, 2, and then finally a 2 to a 5. But the biggest thing is, notice how we have our x values here of -1 and 1, but they are both mapped to, in this case, a +2. So we are not going to be one-to-one in this case because we have different x values mapped to a single y value. Now, if that y value were, say, a positive 2 and a negative 2, we would be good to go. But in this case, they are not. So we can conclude that this one is not going to be 1-to-1. So not 1-to-1. And the reason is each x should be mapped to one y, but there's at least one y corresponding to more than one x. So let's go ahead and look at C. We're dealing with a table of values. Our left-hand column represents our year, and our right-hand column represents our number of hurricanes. So we have a 2009 year associated with 2 hurricanes. We have 2010 associated with 12 hurricanes, 2011, 7, 2012, 10, and 2013, 2. So notice how we have some repeating values for our right-hand column. We have this 2 here, and then we have a 2 here. That is not necessarily what we wanted. What we have is a y corresponding to more than one x value. So again, we can go ahead and say that this one is not 1-to-1. All right. So next we can move on to finding equations of the inverse. So let's go ahead and try to find equations of an inverse. So for a 1-to-1 function, f is defined by an equation y is equal to f of x. Find the inverse of the defining equation as follows. So first step, you're going to go ahead and interchange your x and y. Then you're going to go ahead and solve for y. Once you have solved for y, you can go ahead and take that y and replace it with f inverse of x. So let's go ahead and look at these equations here. So finding inverse equations, the directions state to determine whether each function defines a 1-to-1 function. If it does, find its inverse. Now if it doesn't, then we can go ahead and conclude that it fails our horizontal line test, or it's not 1-to-1, so there's not going to be an inverse for it. So for our first example, we have f of x is equal to the absolute value of x. Let's go ahead and see if we can go ahead and find the inverse on this one. So first thing we want to do is set up our graph. So we know that the absolute value of x kind of looks like a V. So drawing our horizontal line, notice how it's going to cross, in this case, at 2 points. That's not really what we wanted. So this one is going to go ahead and fail the horizontal line test. So we can say fails horizontal line test. Go ahead and abbreviate it, horizontal line test. And what does that tell us? Well, it's not 1-to-1. So in that case, we can't find an inverse because we wanted it to be 1-to-1. Now, how about our second one, our line of 4x minus 7? If we draw a horizontal line on this one, notice how it doesn't matter where I draw it, it's only going to intersect at one point. So this one actually passes our horizontal line test, which means that we need to go ahead and try to figure out what the inverse is. So let's go ahead and write what we know so far. It passes horizontal line test. So passes horizontal line test. So indeed it is going to be 1-to-1. And we can go ahead and go through our different steps to figure out what our inverse is going to be. So our step number 1 in this case is go ahead and take your x and y values and interchange. So interchange our x and y. So interchanging our x and our y values, again, if you recall, g of x, we could actually replace that with a y. So y is now going to be equal to 4x minus 7. And we want to go ahead and interchange our x and our y's. So x is going to be equal to 4y minus 7. And we want to go ahead and solve for y for step 2. So solve for y. X is equal to 4y minus 7. Go ahead and add your 7 over to the left-hand side. So that gives you x plus a 7 is equal to 4y. And then the last step you want to do is divide by 4. So that should give you a y is equal to an x plus 7 divided by 4. And for step number 3, you can go ahead and take that y and replace it with f inverse of x. So in this case, we would replace it with g inverse of x because we were initially dealing with g of x. So g inverse x is equal to, what did we find? X plus 7 divided by a 4. And if you wanted to break it up into fractions of 1/4 x plus 7/4, that is okay as well. So we should be good to go for our example of B. Now let's go ahead and look at our example C here. So looking at our example C, what do we have? We have our graph of x raised to the third plus 5. So if we draw a horizontal line here, it doesn't matter where we draw it, it's only going to intersect at one point. So we can go ahead and conclude this passes our horizontal line test. So passes, in this case, horizontal line test. So this one is going to be 1-to-1, which means we can go ahead and try to find the inverse. So 1-to-1, let's go ahead and perform step 1. Step 1 says to go ahead and interchange your x and your y values. So again, we can go ahead and take that h of x, and we know that it's actually also equal to y. So y is equal to x raised to the third plus 5. And interchange your x and y values. So x is now going to be equal to y to the third plus 5. And we can perform our operations to figure out what we need to do next. So step 2. We want to go ahead and solve for y. So step 2, solve for y. So solving for y, first thing we need to do is go ahead and get that 5 over to our left hand side. So let's go ahead and subtract it. So subtract, and that should leave us with, in this case, an x minus a 5 is going to be equal to a y raised to the third. Now, in order to get rid of this degree of 3, we can go ahead and take the cubed root of both sides. So that should leave us with y is equal to the cubed root of x minus 5. So we can go ahead and move on to step number 3, which says to replace that y with, in our case, we are dealing with h of x, so in this case, h inverse of x. So step 3, replace with, in this case, h inverse of x. So y is now going to be replaced with h inverse x. So that gives us the cubed root of x minus a 5. So we should be good to go for our part C, and we can go ahead and move on. So next is finding equations of the inverse of rational functions. So let's go ahead and look at this example. In this one, we're given that this function is already 1-to-1, and we want to find its inverse. So f of x is equal to negative 3x plus 1 divided by x minus 5, where x is not equal to 5 because that would make the bottom 0, or in other words, we would be undefined. So we're given it is 1-to-1, so we can go ahead and jump into our steps here. So step 1, interchange our x and our y values. So step 1, interchange x and y. So interchange our x and y. Again, we know f of x could also represent our y. So y is equal to negative 3x plus 1 divided by x minus 5. Now we need to go ahead and interchange our x and y values. So x is now going to be equal to a negative 3y plus 1 divided by a y minus 5, where we don't want that bottom to be equal to 0, so y cannot be equal to a positive 5. So step number 2, we need to go ahead and solve for y now that we've interchanged our x and our y values. So in this case, let's go ahead and move on to step number 2. So step 2, let's go ahead and figure out what that is going to give us. So solve for y. Okay, so given our original, we have x is equal to negative 3y plus 1 and y minus 5, where y is not equal to a 5. And first things first, let's go ahead and multiply that y minus 5 out of the bottom. So multiplying y minus 5 out of the bottom, what does that give us? It gives us an x times a y minus 5 is equal to a negative 3y plus 1. Okay, let's go ahead and see if we can do a little bit more simplification here. So that should give us, in this case, an xy minus 5x is now equal to negative 3y plus a 1. So what can we do here? Well, we can go ahead and add our 3y over to our left-hand side. Okay, so that should give us an xy plus a 3y, and then finally minus a 5x, so minus 5x. And that's going to be equal to a positive 1. And essentially, what we want to do is get that 5x over to our right-hand side. So let's go ahead and add a positive 5x, add the positive 5x. So that gets me an xy plus a 3y is equal to a 5x plus a 1. Now, notice how on the left-hand side we can take out a y. So let's go ahead and take out a y here. So y will now give us an x plus a 3, and that's going to be equal to a 5x plus a 1. So if we wanted to go ahead and isolate this y, we can finally divide by the x plus a 3 on both sides. So that should give us a y is equal to a 5x plus a 1 divided by an x plus a 3. So at this point, all we have left is step number 3, and step 3 says to take our y and replace it with f inverse of x. So step 3, we can go ahead and replace, in this case, our y with our f inverse of x. So in this case, f inverse of x is now equal to what we just found of 5x plus 1 divided by an x plus a 3. Next, we will look at graphing f inverse given the graph of f. So say, for example, the graph of f inverse from the graph of f. It is found by locating the mirror image of each point with respect to y is equal to x. So say, for example, the point of a comma b is on the graph of a one-to-one function point b comma a. Again, our x and values, they were just interchanged. And that is going to be our graph of f inverse. So we want to go ahead and look at these two graphs here to determine if the functions are indeed inverses. So keep in mind that we want to go ahead and see if they are the mirror image over the line y is equal to x. So for this first example, we have two functions. So we have our blue line and we have our green line. Notice how we wanted them to be the mirror image across this line of y is equal to x. We do have some symmetry going on, but it is not the mirror image across the line of y is equal to x. So this one, we're not going to have functions that are inverses of one another. Now, for the second example, we want them to be mirror images across this line of y is equal to x. Notice how we do have that indeed. We have our blue and our green lines which represent our functions, and they are the mirror image across the line of y is equal to x. So we should be good to go there. So our last example here is going to be finding an inverse with a restricted domain. So normally if we just had our graph of x squared plus 4, that one would fail our horizontal line test, but notice how in this case it tells us x is less than 0. So again, we're going to go ahead and look at only this left portion here. So we should be good to go. Let's go ahead and perform our different steps. So step 1, interchange x and y. Step 1, we can go ahead and say interchange x and y. So interchange, and then we're dealing with our x and our y. So interchange x and y. Our f of x is equal to x squared plus 4. So y is going to be equal to x squared plus 4. And we can go ahead and interchange our x and y. So x is going to be equal to a y squared plus a 4. So that will give us, in this case, we can go ahead and move on to step 2. So step 2, what is that going to have? Well, we want to go ahead and solve for that y. So solve for y. In this case, we want to go ahead and take our 4 and go ahead and subtract it over to our left-hand side. So we were left with x minus 4 is equal to y squared. Go ahead and take the square root of both sides. So y is now equal to the square root of x minus 4. And we can now move on to step number 3. So step number 3 says that we can go ahead and take our y and replace it with, in this case, a f inverse of x. So step 3, replace y with f inverse of x. So that will give us, replace that y with f inverse of x. So f inverse of x is equal to the square root of x minus 4. And again, inside of our square root here, we want x to be greater than or equal to a positive 4. Because if we have it less than, in that case, that would get us a negative under our square root, and we don't necessarily want that. So our last topic that we will look at is going to be facts about inverses. So facts about inverses, number 1, if f is a one-to-one function, then f inverse exists. So number 2, the domain of f is the range of f, and the range of f is the domain of f inverse. Number 3, if the point of a comma b lies on the graph of f, then b comma a lies on the graph f inverse. Now, this is found by reflecting over the line of y is equal to x. So in other words, you can take your x's and your y's and interchange them and figure out what that graph looks like. Okay, our last point here is 4. To find an equation for f inverse, again, replace f of x with y, interchange x and y, and then solve for your y, resulting in your f inverse of x.